Okay, Chapter 8, Bivariate Correlational Research. So this is doing studies that make association claims, and we're investigating two quantitative variables. Typically, the data that you're analyzing here is depicted in a scatter plot, and the analysis that's used to investigate the relationship is called correlation analysis. Pearson correlation is a typical one. And correlation will give you a correlation coefficient, which is symbolized by R. Okay, so here's some data score on well-being, and this is reported conversations rated as deep talk percentage. And this depicts the relationship between the two. You can see higher on well-being means higher percentage of deep talk, and this has an R of 0.28. So 0.28 is probably a significant correlation, and the closer a correlation gets to 1 or -1, the stronger it is. This one is positive because it trends upward. This one here trends downward, so it is a negative association, negative correlation. And both of these, positive and negative, are both predictive if they're significant. And if this was closer to -1, like -0.8 or 0.9, it would be even stronger and more predictive. But it's not like positive is good and negative is bad. They're both good for making predictions. It's just a different direction. Okay. One important thing to note is that when you're doing correlational research, you're studying two measured variables as opposed to manipulated variables. So you're not doing an experiment where you're actively manipulating some independent variable and then observing how the dependent variable changes as a result. You're just investigating the relationship between two variables and seeing if they're related. We'll go through the four big validities here. The two most important ones for association claims like this are construct validity and statistical validity. So I'll unpack those more. Internal validity, we shouldn't be making causal claims from correlational research. It's often tempting, but correlation does not equal causation. Now, related to internal validity, though, is the third variable problem. That's something that you should investigate in the context of an experiment as well. But it's also important for interrogating association claims. Even if you're not claiming causation, it's important to consider what other third variables might be driving the relationship that you find between two. Okay, and then external validity, this is, of course, deals with generalization. To really generalize, you need random samples. Many of these studies don't have those, but you can often still have meaningful results, even if you don't know how externally valid a correlational study is. Okay, so construct validity. This deals, of course, with how well each of the variables was measured, how well it captures the conceptual variable that you're getting at. Do the measures that you used have good reliability? Are they measuring what they are intended to measure? Does it have good face validity? Does it look like what you subjectively look like what you intend to measure? Does it have good criterion validity? Does it correlate with relevant behavioral measures? And then discriminant and convergent validity, does it correlate well with known measures that are similar, and does it not correlate with measures that should be dissimilar from it? Okay. Internal validity, there are these three causal claims, and these three causal criteria, three criteria for establishing a causal claim. Okay, one is covariance. Now, you can find covariance all day long with correlational studies. That's what they're all about, but that's only one of the three. So if you have that, it doesn't mean it's a causal claim. Temporal precedence, sometimes you have temporal precedence when doing a correlational study, but oftentimes you have this directionality problem where you don't know if it was, well-being that came first that then led people to engage in more meaningful conversations, or if it was people engaging in more meaningful conversations which then led to them having more well-being. Okay? So it's a chicken and egg problem that you often deal with. Okay, internal validity. Again, we shouldn't infer causation from correlation alone, but but it's important to still consider the third variable problem, even if we're not considering causation. Now, it may not always be an issue. Here are a couple of examples, or here's an example of where the third variable problem might be an issue and where it might not be. Okay. So here's hair length and height. Okay, and if you just lump all these dots together, then there's a significant negative correlation. Okay, the taller you are, the shorter your hair. Okay, but in reality, there's a third variable here, and that's gender. Okay, so if you split this into men and women, men just tend to be taller on average, and they also tend to have shorter hair. Okay, so it's not like within each gender there's really a significant relationship between the two, and so it's just a random cloud. There's no trend to either gender, but if you combine them together, then that third variable has an effect, and you get a significant negative relationship. When you look at height and weight, however, this third variable of gender doesn't really affect it. The relationship exists across both genders, where height is correlated with weight. Okay. Of course, men tend to be taller and tend to weigh more, but that's the case with both genders, that taller women and taller men tend to weigh more than shorter women and shorter men. Okay. External validity. This is, again, not an automatic justification for rejected results if you don't have a random sample, but it should be tested in other populations just to see if the relationship holds. Okay, so this is the MTL thickness and time sitting study. So this was done originally in older adults. Maybe the relationship exists there. If you completed this study in younger adults as well and you saw the same relationship, then that would be good evidence for external validity. Okay. One way that you can get at this statistically is looking for a moderating variable. Okay, so moderating variable is a variable that when it changes, then the relationship changes. Okay, so the relationship between two variables will change depending on the level of the moderating variable. Okay, I know that sounds kind of wordy. This is kind of what it looks like. Okay, so you have this relationship between percentage of wins of a baseball team and then attendance at games. Okay, if there's a positive correlation, then that's kind of an indicator of fair weather fans. They only like to go to games when they're winning. And here in Phoenix, Arizona, there's a high level of residential mobility. So residents tend to move in and out of Phoenix more often than in Pittsburgh, where there's low residential mobility. And here, there's not really much of a relationship between percentage of wins and attendance. So in Pittsburgh, they're more diehard fans. They attend games whether the Pirates are winning or not. Okay. So here, this relationship that's observed here does not generalize to Pittsburgh. So there's actually a moderating variable here, and that is residential mobility. Okay, so as residential mobility changes, when there's different levels, high versus low, then the relationship between attendance and percentage of wins will change. Okay. All right, there is, I forgot to mention there's a part 2, and that's when we're going to talk about the statistical validity of correlational studies. Okay, so that's the end of this one, and we'll continue in part 2.